just to note that we are going to record this webinar and we are going to be asking for your participation. So just keep that in mind, what your comfort level is with participating by audio or by text. It will be recorded for internal use only. We're not going to share it publicly, just so you know. So I'm Alana Westwood. I'm Evidence for Democracy's research coordinator, and I'm also the coordinator for the network of experts, which many of you are members of, or you've been invited by somebody who is a member of the network of experts. I've been with E4D for just under 2 years now, and before that, I was a volunteer with E4D right since the beginning of the organization. In my other life, I also work as a conservation scientist, as a consultant, working with the Boreal Avian Modeling Project, Environment Canada, and others. And in terms of my own communications experience, I've a long history of advocacy work that has led me into the press numerous times, TV, radio, op-eds, all kinds of different interactions with reporters, which have been, well, as we'll get into sort of the nuances of it, it's a really mixed bag, and there's a lot of skills that I wish that I'd had early on, that I'm hoping that we can discuss those skills and share some of those skills with you today. So Adam, if you could introduce yourself.
Yeah, sure. Just let me know if you have any problems hearing me. I'm put my phone on speakerphone and put it down so I don't make too much shuffling noise. Is this level okay for you?
That works for me.
Okay. So I'm a professor in the Department of Biology at the University of Ottawa. My area of expertise here is oriented towards aspects of science education, particularly the scholarship of teaching and learning science at the undergraduate level. And one of the subcomponents that I think is an important aspect of this is science communication and imparting skills in science communication towards our future scientists through the programs here. My background that brought me to developing these skills was largely through growing up in a performing arts community. Since I was a very young child, I performed music and dance and bouts of theater in international audiences. So I feel that I've come about these skills quite practically through this life in the arts, and I think that it translates rather well into science communication, given that there's a lot of overlap in those.
Thanks. I just want to check in. I've had one person mention to me that they cannot see any slides yet. There is on your bottom of the bar, there's a number of different icons. There's one that's sort of a speech bubble. If you want to click on that, and if folks participating could let us know in the chat if they can see the slides or not, that would be great. Okay, some people are chiming in that they can have the slides. So those that can't, sometimes it takes a little while to load. So be patient, or you could try leaving and rejoining if that doesn't work for you. Great, thanks. So I'll just introduce Evidence for Democracy. Most of you are probably familiar with E4D, and also we have E4D's Interim Executive Director, Kathleen Walsh, here. She's moderating. Perhaps you could introduce yourself.
Hi all, I'm Kathleen, and I will be helping out for the webinar. So I will help relay your questions as we go along to the presenters. And yeah, I will be here to help. So as you go along, if you do have issues, you can put them in the chat, and hopefully I can help address them. And happy to be here.
Great, thanks. And yeah, as she said, you can either message her directly through the chat, which I'll get into, or just group chat that you're having issues, and then we'll figure out how we can get you seeing the slides and participating. So E4D is close to 3 years old already, actually, an organization that's developed out of the need to promote the use of evidence in government decision-making, evidence-informed policies. It came out of the Death of Evidence rally, which happened in 2012 during the Harper government. at which there were drastic cutbacks to science in the scientific community, sort of rose up and said, you know what, we need to change this situation. We're losing our place as leaders in science, national, on the international stage. We're losing our own country's capacity, and sort of out of that momentum was born Evidence for Democracy. And so E4D's approach is three-pronged. We work to educate Canadians all across the board about what role evidence has in government decision-making, and that also includes skills training through webinars like this one, so helping equip gatherers of evidence and both those who want to be able to use evidence on how to disseminate, interpret, use evidence in policy. We also do original research. That's my wheelhouse. I'm the research coordinator. And then finally, we do individual issue-based campaigns around particular legislation or in particular provinces where there's a need to address how evidence is or isn't being used in policymaking. Okay, so I'll give you a little quick tour of the webinar software. You probably haven't used Fuse before. It's pretty new. This is our first time trying out a webinar in Fuse. We may have a few hiccups. We may have had a few already, so I appreciate your patience. So as I mentioned, on the bottom, you have icons. There you'll find the chat. The chat can either be a group chat to everyone, or if you click the plus sign, you can start an individual chat with one of the organizers, so either Kathleen or myself. So if you have any concerns, please feel free to do that. Another way that you can interact is on the bottom right corner, you'll see 3 dots. That's your menu. And if you click on that, there's an option to raise your flag. So what I'd like you to do is just try raising your flag. So click the 3 dots and then, all right, I see a whole bunch of flags, great. And then can you lower your flag again? Perfect, thank you. So I just want to get a feel for the folks who we have with us. If you're a researcher, whether that's social science, health science, natural science, engineering, you consider yourself someone who does research, raise your flag. Okay, it looks like almost most of the people here would identify as researchers. So I'm going to lower everyone's flags. If you have ever talked to the press before about your work, raise your flag. Okay, quite a few. So looks like about 1/3 of the participants on the call have actually spoken to the press about their work before. So as we go, there will be times we might ask you to raise your flag, to just give us some feedback throughout. And the other main way to interact is with the chat. So I would also like, in the group chat, could you let us know just briefly in a sentence or two, what are you hoping to get out of this? Are there any particular skills you want to learn? Do you have any expectations for things that you hope to cover? Let us know some of your aims and goals you want to get from this webinar. Finally, with regard to the technology, we can also unmute you. So there is going to be parts where we're going to ask for folks who want to contribute using their voices, using their audio connection. If they want to contribute, what we'll do is we'll ask people who want to contribute to raise their flag, and then we can selectively unmute you so that you can share your story. So this way we don't get all kinds of noise from everybody being on the call. You can just hear the one person speaking. If you may be able to see a bunch of people's names, participants at the top. If you want to see the PowerPoint a little better, there's a space with 5 gray dots. You can drag that up and that'll just kind of blow up the PowerPoint so you can see a little better. So just to share it with Adam, some of the comments that we're getting. Lisa shared looking for strategies to improve communications with lay audiences regarding research. James, how can we communicate better in a post-factual online world? Robert, initiating public attention to a policy issue. Nicole, how to write press releases simply and engagingly. Chantel, how to initiate interactions with the press. And Miroslava, improving communication skills. And then Jenna says, hearing about the state and the future of science communication in Canada. So I'm hopeful that we'll touch on all those points today. I think we will. And you'll have an opportunity later to ask questions on anything we haven't covered. So we expect this webinar to go until about 8:30 EDT. I know you're all over the country, so that's about an hour and a half. I myself am in Halifax. Adam's on from Ottawa, as is Kathleen. I know we have people from BC. We've got folks from up north. So thanks for chiming in no matter what time it is. The first thing that we're going to cover is we're going to look at the foundations of science communication. And Adam, he's got a lot of experience teaching and giving workshops on this. He's going to review why to communicate, both in academia and society. What's the rationale? Strategies for effective communication. And we're going to do an exercise together with your own work on framing. And then part two, which will be much shorter, I'm going to talk about some of the nuts and bolts of how to communicate. So when interacting between scientists and journalists, how can we consider their different worldviews? What is the press cycle and how do you use it? And how do you determine who your audience is? Following that, we'll have a Q&A and then we'll call it a night after that. Okay, so Adam, I will hand it over to you, and I will advance the slides to the best of my ability. But if you could sort of signpost me every once in a while to make sure we're on the same page, that would be great.
Absolutely. Again, my apologies for not being able to join you with the actual software. It may be a little bit more clunky than I was expecting, but hopefully it should be reasonably clear and smooth enough. So if I'm to assume that we're looking at the title page where I have sort of entitled my section, Communication being the indispensable link between scientists and society, I will be talking to you today about the principles and practice of science communication as I see it, and to point out that there is in fact a whole field known as science communication, which is a large and growing field and among the humanities, particularly in Europe and Australia and New Zealand, but it is quite still in its infancy in North America. But as such, I wanted to point out that there are many sort of subdivisions of this study of science communication as it's seen in these by these humanities scholars. In particular, ones that will be of relevance today are the distinction between scientific communication, which would be sort of the high-level specialized communication among and between scientists, and the public communication of science, which is more a form of outreach when there is science being discussed towards non-specialists of any kind of group in the public. So that being sort of the preamble, if we are to look at science as a starting point and its scientists, we may suggest that scientists and even science have gotten a bum rap lately. As Elena pointed out, sort of the impetus for the creation of evidence for democracy was behind the fact that science and scientists have been largely under siege in Canada for much of the past 10 years. And thankfully, the climate seems to have shifted somewhat there. But we could also point to other forms of representation or even misrepresentation, if you will, of scientists being beaten up on sensationalist media, such as Fox or Sun News, or being ridiculed in sitcoms and other aspects of our popular culture. So I like to start out these kinds of workshops with a question: have we got a bum rap? And to follow that with what would you say? And this is your opportunity to contribute a word in your little chat box for us. Would be what do you think the world thinks of us as scientists when they were to think? If a member of the general public were to think of a scientist, what would be the common words that would be used? A typical word to describe a scientist in a single word. Just start typing it out, and perhaps, Alana, you might be able to say what these suggestions are of what the views of scientists are from the public.
So we've got some responses right away. Thanks so much. We've got nerd, mad scientist, evil genius, asocial,
Yep.
all-knowing, remote, pretentious.
Yep.
Someone's family uses that. I can say I've heard that from my own family too. Poor communicator, ivory tower dweller, works in a lab.
Exactly. Exactly. You know, and those are very much the kinds of descriptors that I was expecting. And is that really representative of the public's view of science? Well, if we switch to the next slide, we could consult the court of public opinion, which nowadays we can get quite readily from Google. So I did a quick Google image search, typing in scientist stereotype, and this is what came up in the images. So we see very clearly from the results that these stereotypes that you had just listed off are alive and well. We see a lot of lab coats, glasses, and goofy, nerdy types, and social oddballs, and even some strange, incomprehensibly weird people. And so that, you know, this is the perception that's out there. And so these stereotypes exist, and we well know that stereotypes exist for a reason. So there may be some truth behind this. And obviously, we are all here in order to, in part, acknowledge this, but to move on and try and find a way to improve this relationship that we have, assuming that we all consider ourselves to not be this way, or at least that we are, that we would wish to improve upon this image. So if we switch to the next slide, to ask ourselves why it is that the public largely gets this perception, I think we can point to one aspect being related to the communication from scientists when they are speaking to the public. That the public usually just hears a bunch of mumbo-jumbo jargon, a lot of explicit details about very complicated, complex processes, a bunch of numbers to back it all up. And I think that there's a lot of truth to this. I think for the most part, it is because we are trained as scientists to speak this way as part of our scientific culture. And obviously part of today's workshop is to find a way to move on from this and to develop some different skills to be able to speak differently in a way that reaches the public more effectively, so that not only that we can have better science ambassadors to the public, but also so the public can make better use of scientific information and benefit society as a whole. So that brings to the next slide, the science in society. Why is science important in society? And as we've seen, the perception of scientists by the public can be a bit of a double-edged sword. But if we were to want to have a positive influence on societal interface with scientists, then it may be important to start out by identifying why science itself is important to society. And the top bullet it really refers to something that we probably all would agree with, being for the most part seasoned or scientists in training, that science is important, that there's the idea of exploration and discovery, and that basic research leads to applied aspects through technology and others. And so, but the point is that when we're talking among scientists, it's easy to sort of geek out on the science and just love it for the fact that it's science and we all love that. But for the most part, that's not the perspective from the public, or at least not necessarily what they might see as value of science, that they may be more in tune with the impacts on their understanding of environmental issues that impact, of course, their health, or it could be related to medical and public health aspects. It could be related to the use of technology in their lives, of course, which is an offshoot of the applications of science. And lastly, we have to also recognize the state of the world, that there's an awful lot of nonsense out there in the form of pseudoscience on the internet, and that people with a better understanding of science can better cut through the nonsense to be able to find truth that will be useful to them in their lives and to society as a whole. So if we were to switch to the next slide, I think just through the notion of the modus operandi and the mission of Evidence for Democracy, one of the goals of imparting the public with an understanding and appreciation of science is to create responsible citizenry and to allow and empower citizens to make informed decisions as being part of our democratic society. So we could look at any number of types of decisions that people might make and see how science might actually come into play in those decisions and what impacts that would have retroactively or conversely back towards societal aspects and infrastructure. We could just take, for example, purchasing a car, and that purchasing a car implies a lot of that there are a lot of aspects that have scientific components and also impacts on society based on those decisions, such as we acknowledge that there's this thing called climate change from runaway global warming, and that it would be important for people in general to know about the effect of greenhouse gases on the climate as they are thinking about how this purchase of a car may impact upon that. And of course, it would have consequences on the environment. So there's this interplay between that decision-making, the knowledge that would be required, and the impact that it would have on some aspect that's of importance to society. Another aspect, more technologically related, would be having some understanding about fuel and energy efficiency and how that might impact the economics of purchasing a vehicle. We could obviously talk about political impacts through the decision to support and some politicians over others based on whether or not they are employing evidence-based policies versus ideology. And these would require, on some level, some understanding and application of science in the decision-making as it relates to this benign example of purchasing a car. And also for many of us that are here right now, we acknowledge that our livelihoods, for the most part, are on some level dependent on support, either through public funding or societal attitudes towards our academic research and positions, and that it would be important for us as well that the public is supportive of the research and exploration that we do. And this is directly related to their ability to understand and appreciate what it is as well. So even just some simple and basic decisions as buying a car can have all of these ramifications to various aspects of scientific content and understanding and the impacts that it would have on various levels of society as well. So for the next slide, if you would please, I would like to just take a moment to point out some of the potential negative consequences of a public that may have a poor understanding of science. And obviously, again, this can continue to riff off of this issue of climate change. There's clearly a problem related to the public's understanding of this scientific issue, and this screenshot from Fox News clearly exemplifies that. We well know that Fox News is not really the most reliable evidence-based reporting, but a lot of people get their information from here, and just the way they're presenting this idea that climate change is nonsense because there's no scientific proof is probably playing up upon some misunderstanding of what science does, and that it's not really proving anything as most people understand it, but is building a body of evidence, and that this body of evidence is astounding, and that there's general consensus, but that we work in probabilities and not necessarily certainties. And this sort of ambiguity about science probably leads to a lot of confusion that can be then exploited by those that wish to create controversy out of it. And we well know that climate change denial can be a real problem, as climate change will be clearly the major challenge for our time and in the future. So on the next slide, we can see one of the consequences of this confusion in the public, this notion that one can believe believe or not believe in facts, which we all well know that belief is not necessarily a form of knowledge, does not require evidence, but it leads to important consequences in the public. Here we have another screenshot from the Wall Street Journal, again, not necessarily the most left-leaning or enlightened news outlet, but one of the things that we see here is actually the important part is right down at the bottom, these sort of polls that they do, getting opinions from the public. And what we can see here is that this poll from yesterday's topic was asking, do you believe humans are responsible for climate change? And first and foremost, I mean, we can see that the results here are that only 11.9% say yes and 88.1% say no, and that's obviously a problem because, well, it leads to issues related to being able to address this climate change. But I mean, more fundamentally, I think we can agree that it's not about whether you believe something or not. It's about whether it is or it isn't, and we know that it is. And to allow people the option to disbelieve that it is because of some false identification or equivalency of belief with knowledge is a problem. And I see that as well as being one of the consequences of poor scientific communication and leading to a poor public's understanding of what science is, when we should actually have our policies based on evidence as opposed to public opinion or beliefs about something. So another example, obviously, if we turn to the next slide, we could point to problems related to vaccination denial, anti-vaxxers, and its effects on public health. We well know that there's a massive online campaign built around the idea that vaccines are bad for you and that they may lead to children developing autism. And we know that this is categorically false, and we know why it is thought to be true because of a fraudulent article from 1998 published in the British medical journal The Lancet by Wakefield and colleagues that was since retracted, showing to be fraudulent, and they retracted in disgrace by the scientific community. But clearly the effects still linger. And this is something that's very important to aspects of public health, and we must consider this to be a problem, and it is a problem that is in part due to the historical fraud that was committed, but otherwise the problem relates to the scientific community's inability to communicate the actual science effectively and to counter those pseudoscientific claims made by the anti-vaxxers. So just to look at consequences, if we switch to the following slide, we can see from this graph from the Center for Disease Control that vaccines are effective in eradicating disease. And one consequence of this pseudoscientific nonsense that's out there is that many communicable diseases may have be on their way back in some pockets where anti-vaxxers have had success in preventing people from vaccinating their children, and diseases that were once eradicated for decades, such as measles and tuberculosis and polio, that are making a comeback. And I think we can point to that some of this effect is due to the fact that vaccines do work, and many of us do not have memories of our childhood friends dying from whooping cough or TB. So thanks to vaccines. But I think part of it is also due to the fraudulent science that's out there that confuses the public into misunderstanding the nature of the science that's meant to protect them, and therefore this is also another failure of the scientific community's ability to effectively communicate science and its values to the public. So moving to the next slide, I'm now going to shift a little bit into a discussion about how we communicate as scientists and how we may be able to better communicate to the public. But I'd like to point out that it's not necessarily true that communication is not part of our training. It is. In fact, it's a very important part of our training as scientists in university programs of science. And in fact, communication is a big part of academia, and this slide sort of bullets the various levels at which communication occurs in academia semi-regularly. The highest level being intradisciplinary communication, and this is when we have highly specialized communication among experts talking about their specialized field to one another and in manuscripts and journals and conferences and the likes. And then we also have interdisciplinary communication where, again, expert scientists from somewhat different but closely related fields may discuss aspects of their science as they relate to one another in more broad or general types of venues, and again, typically academic journals or conferences. And then we have these two other levels. The pedagogical level of science communication is essentially when we teach students to become the scientists of the future. And lastly, this communication to the public, which is generally known as outreach, whereas it is encouraged by our institutions. It is probably the one kind of communication that is least undertaken by most academics. On one level, because we do not have necessarily the incentives from our institutions to have them acknowledged in our workloads and so on, but I think obviously because we are generally lacking the skills to know how to be effective communicators to the public, whereas these other levels are more generally accepted as part of the norm of being a scientist in academia. So this idea that communication is an integral and important part of academia, I think, is absolutely clear, but the way we communicate and the way we've been trained to communicate has been more in these upper levels, as we discussed, to ourselves, to our scientist colleagues, to our future scientists, and that these types of communication are not conducive to talking to the public. And I will switch the slides to the next, which will illustrate how we communicate science among specialists and why that's not necessarily the best way to go about communicating to non-scientists. So most specialized forms of scientific communication follow this model of going from the general level to a specific level, where you will probably all recognize this idea of starting out very generally with an introduction, laying down the context for our study or our talk, and then getting a little bit more refined and detailed to what we did and how we did it with materials and methods, and then more specifically what we found from those procedures in our results, and then lastly what we got out of it in the conclusion, and then discussing that conclusion and relating its importance back to the generalities of the field. So I think we could also recognize that even the whole academic process mirrors this structure, where in the early years of our program we're in more general courses in biology and chemistry and physics, and then we move up and we get a little bit more specific in biochemistry and genetics and statistics, and as we move up we get to more specific courses that may suit the original intent for enrolling in these programs and being able to study the animals or the plants or what have you. But this whole notion of general to specific is built into the very fabric of everything that we know about communicating and learning science. And it is basically the wrong way to go about when communicating to anybody who's not one of us, if you will, one of these sort of highly specialized scientists. Well, for one, because we can't necessarily expect that people who aren't scientists would be inherently interested in knowing about what tools we used or how many microliters of this or, you know, what milligram of that or what was the p-value of this or that, the other. They're not necessarily interested in that. And what they might be interested in would be the conclusion and its relevance, but of course it takes 20 minutes of a conference talk before you get to that point, or even worse, 20 pages of some highly complex published manuscript before you get to the sort of the conclusion of it all, by which point most of the non-specialist audience members likely be totally zoned out and we've lost their interest. So if we turn to the next slide, communicating science to non-specialists would effectively be quite the opposite, that we should go from specific to general as opposed to general to specific as we've been trained throughout our whole academic and scientific career. So the idea here is that we should, get to the point right away. The bottom line is get the take-home message right out of the way. Why am I here? Hi, I'm Adam Brown. I'm here to tell you that I've discovered a new form of energy. And at that point, the audience is interested in knowing, how and why we got to this, and you can start to generalize once the specific message is out there, and we can maintain interest from the audience by adapting it to the relevance to the things that they already know or are interested in. So what, what's the implication of this? And then we can sort of fill in the background information and context afterwards. And this sort of flipping it on its head approach is one of the first recommended structural changes to our communication when we're speaking to anybody other than our highly specialized colleagues. So if we were to switch to the next slide, another aspect of communication involves recognizing who you're speaking to. So we've already identified that the point of this kind of workshop is to find out what it's like to speak to non-scientists and how we should go about doing that. So we've already identified that our audience is not a group of scientists. So this whole communication 101, sort of the basics of the actual academic field of communication, the most fundamental principle is typically know your audience and then thereafter speak to that audience. So speaking to that audience means don't speak to different audiences in the same way, because not all audiences are the same. Now at this point, we're going to leave behind speaking to scientific audiences and address what it would be like to speak to any other non-scientific audiences, but also to recognize that if we were to talk about speaking to the public, and we'll switch to the following slide, that the public is not a uniform group. The public, as opposed to scientists, are, well, I guess I'll backtrack and say that not necessarily as opposed to scientists, but if we're talking about scientists being specialists and have been trained in this sort of specialized communication, the public, which has not, is also made up of quite a big variety, a diversity of special interest groups, different demographics, different sectors of society with different interests and different values. So this idea of speaking to the public, it's not a one single group. Within the public, we have to identify, well, what subgroup of the public are we talking to on any given instance, and to adapt our communication specifically and specially to the group to which we are speaking. So that leads to this concept of framing, which is on the next slide. Framing is, again, one of these communication techniques, which is basically is tailoring your talk to meet your group on their level. Now, when I say on their level, I don't mean that we should be dumbing it down because we're so intelligent and they're so stupid. In fact, that is not an effective strategy, because it's apparent, and being condescending is one of the stereotypes that we're often accused of, and for good reason. We should not be condescending. This idea of framing is adapting or tailoring one's communication in such a way that it resonates with the audience, that it meets them at the level of their interest, that it resonates with their own values. So it's important to note this is not the same thing as spin. There's nothing deceitful about framing. You're not lying or presenting false information, or everything should, in principle, be true. And again, it's not dumbing it down, but it's really talking to your audience in such a way that they're able to understand it and to see how the information that you're presenting to them is of relevance to them and aligns with their own values. So this, obviously, you can see, is dependent on understanding who your audience is and working actively towards adjusting your communication so that it meets them on these levels and resonates with their own values. So if we were to kind of stay on this environmental biology theme and ask ourselves, well, how would you frame, say, the discussion of climate change to different kinds of public groups, we can see this woman scientist in the middle of the slide here thinking about how to communicate with any number of groups and how to communicate specifically with one or the other. If we go to the next slide, if she is contemplating putting together a communication that may be talking to families, such as in the context of a town hall meeting where people are going to hear about something that's of relevance to their community or their neighborhood, some daytime TV or radio general interest program, as examples, the conceptual frame of the concern for the family would be a good entry point to draw them into the discussion. So instead of talking about the biogeochemistry and climate forcing and all of these various technical aspects of climate change, you may emphasize the potential impacts on the well-being of their children and their grandchildren, discuss the aspects related to clean air and stable climates and potential political ramifications from displaced people as refugees or submerged cities and places that we know and love as sea levels rise. And as you note, none of this is a spin, none of it's deceitful, but what it is it's addressing the topic in such a way that it may impact these people by resonating with values that are of importance to them. So if we look at the next slide as another example of framing for a different audience, if we're speaking to a business group or a business person, this woman scientist may want to point out that green business is a profitable approach now and in the future, that it's no longer simply a moral issue. We may expect that some business types will be concerned about morality. We don't necessarily know that that's true, but if we focus on the economic aspects of the discussion and how that if they were to shift their environmental values in production or marketing, what have you, so that they align more with those of their clients, they may be able to profit economically from this green market and be commercial leaders in the process of change by aligning their business and profits with those values of their clients and consumers, right? So again, not about deceiving anyone, but it's just about talking about this in such a way that we can agree that it's important because of reasons that are important to you. So for the last group as an example, the next slide, please. If the audience person in question is a nature lover or is an ethically, morally driven person, maybe highly religious, for example, you could probably appeal to their sense of moralistic obligation and the obligation of shepherding nature, protecting biodiversity for ethical reasons, and wanting to minimize harm inflicted upon nature and to emphasize the moral component of doing the right thing and being good human beings. So we're remembering that the goal of this is to inform people about what you're talking about, to get them on board, to get them to agree that it's important because the things you're talking about are important to them. It's not necessarily, the outcome would not necessarily be to get everybody to agree exactly on every aspect, but it should be seen that one of the goals should be to make it so that we have fewer disagreements and that we have better disagreements, and this would be a way to move forward together as opposed to creating these conflicts and disputes that seem to be one of the natural consequences of scientists lecturing the public on how smart we are and how they should be doing what we tell them to do. Framing and resonating with their values is a good way of moving forward together as opposed to antagonistically. So if we move to the next slide, I'd like to talk about this notion of the language that we use and how jargon is a barrier to the effective public communication of science. We recognize that jargon plays an important role in the academic endeavor of science and scientific communication. That, you know, this rigid academic tone and the highly specialized terms that we use are effective in our academic endeavors because they reduce ambiguities among those that understand the meaning and the context. But not many people outside of our fields do understand the meaning and context. And so by using words that have very specific meanings in science, they may lead to misunderstandings in public, and therefore that's another means by which the public communication of science can break down between scientists and members of the public. So one important aspect to consider in tailoring your science communication to the public would be to avoid using the highly technical terms in science and to rather explain things as you go. Also, there are many terms that are just sort of just hot potatoes in science that typically get misunderstood. We think that they mean a certain thing, and they do to us, but most of the public think that they mean something else, which has been illustrated, I think, pretty well in this table, where we can see a number of scientific terms, theory, values, positive feedback, and we know what they mean, right? You know, a theory is not speculation, but that's what the public hears when they hear theory. Well, it's why they can say, oh, that's just a theory, because they think that theory means we're just guessing, that we're speculating. And we well know that a scientific theory is supported by thousands of scientific facts that have not been refuted or falsified, but that's not understood by the public. So let's not use words that just lead to confusion. Why not say the scientific understanding of this or that is such, so that the public does not have the opportunity to misunderstand what we're saying. Let's just choose our words more judiciously, especially those ones that typically lead to confusion. So a couple of others, we don't need to go through them all, but if we say we've manipulated the data, that sounds kind of fraudulent to most people. It sounds like we're tampering or cheating or fixing it in such a way, and that's not what we mean by it. We mean that we processed it. It's a regular activity in order to get the statistical values or the mathematical equations to fall into place. But it typically leads to confusion, and the best alternative is to choose another way of describing what you mean to say. Don't rely on the jargon. Rather explain what it is that's happening. So one of the ways in which we can avoid the jargon, and this we would switch slides at this point, is to not rely on explaining or using the very detailed, complex aspects of processes or procedures, but rather to replace it with some powerful and easy to grasp concept or explanation, for example, using metaphors. Now, interestingly, metaphors give people a visceral physical response when we hear a metaphor. In fact, if you look at people's brains when they are hearing metaphors, the parts of the brain that light up under MRIs are those related to the sensory aspects of our reception, as opposed to specifically the linguistic ones, which means that when we hear a metaphor, we actually feel it. We physically feel the information as opposed to processing the language aspects. This is why expressions like "I smell a rat" gives you this gut feeling, as opposed to my instincts tell me that something's not quite right about this situation. And that latter phrase would tend to be processed in the more linguistic aspects of the brain. And so when we hear "I smell a rat," we instinctively get a sense of a stench, and we turn up our nose and we get this gut feeling, and that is the impact of metaphors. And this is why, of course, it's so effectively used by politicians. For example, JFK was widely recognized as a great orator. He was often using metaphors to inspire people. I've got a quote here where in his inaugural speech he said, "The energy, the faith, the devotion which we bring to this endeavor will light our country and all who serve it, and the glow from that fire can truly light the world." Yeah, you can hear the crowds going wild, and what does that even mean? I'm not even sure what that sentence is really meant to mean, except it's sort of galvanizing support. And the point is that you don't really need to have people intellectually or linguistically process this if the point is to get them to feel something. And metaphors can do this. So many politicians use these. We can think of George H.W. Bush's 1,000 Points of Light. We can point to Rob Ford's gravy train, and perhaps recognize that gravy train may have turned into a bit of a train wreck, taking that metaphor a little too far. But the point being that metaphors have impact. Why don't we use them as well? And so a properly crafted metaphor can replace the need to explain things that might be too complicated or too complex and lead to a communication breakdown. So as an example, we can switch to the following slide to see how biological metaphors can be employed in the public communication of science. It's been a long time since I was actually in the a botany or a plant science course or class, but I think most of us will recognize what's happening here in this process of photosynthesis in the thylakoid membrane of chloroplasts and plant cells, where photons are being excited by photons from light energy exciting electrons, and these excited electrons get passed along chlorophyll pigments in photosystem 2, and the electrons in their highest state of excitement then are taken up by an electron transport chain through electron acceptors, and then passed down through proton pumps, creating concentration gradients that will be used to generate ATP, et cetera, et cetera, et cetera. I'm the point here is that this is highly, highly complex stuff. I'm already lost. And so if you were to try and explain the concept of the process of photosynthesis in this way to the general public, it would largely be ineffective, and you would lose most of your audience. So if we were to switch it into a metaphor, which is what the next slide represents, we see here one of these sort of circus lever type games where somebody is causing an electron to jump up to some higher level of energy using this photon hammer, and that as it rolls down this ramp, it powers a mill, and that the mill can be used to make energy, which is known as ATP, and that ATP then is used to power cells and so on. This conceptual explanation, I think, would be readily understood by most members of the general public, and we recognize that it's not important for them, for the most part, to know this idea about electron acceptors and proton pumps and transport chains and all that kind of stuff, because for the most part, these kinds of communications are not meant to be a biology lesson as much as they are some sort of enlightenment or informing about a process. And if they can get the gist of the process through a metaphor, that would usually suffice, and is a much more effective way of transmitting this information through your communication than trying to, use our traditional methods, which involve all of the complex processes and jargon associated with it. So in this case, the example is meant to illustrate that metaphors can be a really useful tool in your communication toolbox, in addition to this notion of framing your science to the individual audiences to which you're speaking, and to replace the jargon with either more colloquial vernacular words or just with explanations instead of relying on the content of the terminology itself. So this was more or less my crash course in the practice of the public communication science, some of the skills that can be employed to take it to the public and hopefully engage them in such a way that it will be effective in transmitting the important elements of the science in your communication. And if we switch to the next slide, this is where we could come to an exercise that we could all do together, or you could do in your chat boxes, where we may ask you to come up with a very short description of a science that you do as a scientist, say a 1 or 2 line description of your research, but to tailor it for a very particular audience. In this example, we've chosen 3 kinds of audience types, either a group of small children in a kindergarten class, some policy officials, meaning a member of government somewhere in your field, in an agency of government that is of relevance to work that you do, or perhaps a more general adult audience, being some kind of TED Talk style interface. And of course, the examples, there's no end to the examples of types of audiences, a town hall meeting, a high school audience, a senior citizen group, some kind of professional society, like a medical supply company or a downhill skiers association, or music festival organizers, or some business or investors groups. I mean, the list is as endless as there are different kinds of groups in the public, and we could go through this exercise with every single one of them, recognizing that your framing must be different for each group, that the language that you use must be appropriate and relevant to that group, and that you are likely to want to replace some of the complexity of your science with some more accessible metaphors would be a good thing to do. So hopefully, as I'm speaking and over the next a few minutes, we could have some of you contribute an example of what you come up with for any of these groups. But the last thing I'd like to point out with these tricks, if you will, in the toolbox is to be judicial as well about not overusing them. You can quickly become a caricature of yourself if you're taking this all to the extreme and just talking in nothing but metaphors, for example, and really dumbing it down to the common denominator of language. It's not necessarily an effective approach either. So the thing about this communication is that there's an art to it, that there's a happy Goldilocks zone somewhere in the middle of not too much and not too little. And the trick is to find that thought. There's not really a right way necessarily to do this, as there is, or there are a lot of wrong ways to do communication to the public. And so how do we go about finding that Goldilocks zone, or what might be a right or an effective approach? Well, it comes with careful thought and planning, and of course, practice, practice, practice. So should we do some of that now? Again, I can't see what's happening on the screen, but Alana can maybe take it from here and see if there are any contributions.
I think we've got some folks just composing their contributions still. So please let us know which of these three groups, kindergarten, class, policy official, or TED Talk audience, you would be aiming towards.
I'm sorry, Alana, I don't know if it's just on my end, but you're coming through rather quietly.
How's that? Is that better? Can you hear me now?
Yes, it is.
Oh,
yes.
Excellent. Yes, so please, folks, chime in. Let us know. Pick an audience. Let us know which type. Just one is fine, and give us a 1 to 2 line description of your research. And I recognize we're not all scientists here in terms of like traditional natural science. Okay, we have some feedback from Katie Marshall, who for a kindergarten class would lead with, how do insects survive the winter? For a policy official, would say, how does overwintering affect pest insect population size and geographic area? And for a TED audience, would say, how insects can survive freezing, but people can't. So I'm interested, Adam, in your feedback on any of that.
Yeah, great. Well, I mean, I think that's an excellent contribution. We recognize the common thread throughout them all. I can kind of picture the type of work that this person does, and there's been a deliberate attempt to make it relevant and hopefully appreciated by each group, but by latching on to something to capture their interest, which is an important component. It's not just about informing people, it's also important to excite them on some level, to get them engaged in the communication process. And to that end, I would also just point out that communication is a two-way street. It's not about talking at people or even to people, even though it may be in a sort of a monologic environment, meaning you're doing all the speaking. It's important to recognize that you want to engage your audience member through interest and excitement as well. So good job for those, I would say.
Just waiting to see if we have some other folks weighing in. You can weigh in on just one of those. You don't have to do all three. And if we're seeing if anyone else is going to weigh in, I'll ask you for a situation I ran into recently, Adam. So I was asked here by the Nova Scotia Museum. They're running a big thing for Science Literacy Week, and I've sent an email, and they said, we'd like to feature you, to do something for us to cap off Science Literacy Week. You know, could you do a talk? Maybe we can talk about some subjects. So I replied back and I said, well, you know, I'd love to do a talk on the interface of science policy and the need for evidence-based decision-making and how that impacts conservation. And she wrote back and she said, I forgot to mention, the talk is to 6-year-olds. And
yeah.
And you know what,
yeah.
I declined. I couldn't think of a way to frame that for 6-year-olds. So in a situation like that, is there anything I could have done?
Yeah, can you just repeat the title that you had come up with so I can get
I hadn't specifically come up with a title, but just looking at the interface of science policy and conservation.
Yeah, well, for 6-year-olds, I would say, well, how can science facts help save the animals? I mean, quick, very off the top of my head, but evidence-based. We're basically talking about facts and knowledge, and science facts can replace that. And conservation. Maybe we could say plants and animals. So it's obviously not a full description of biodiversity as we know it, but it probably touches upon what's most important for kids of that age. So the idea is to distill it down to its basic elements, to use a language that is able to be understood. The interface between one thing and another, I think, is probably a technical approach to describing how one thing affects the other. And so just by not saying it that way, we could most likely have more of them understand what it's about. And if they understand it's about and that they think it's, you know, of value to them, then they'll be interested in listening.
I should have called you last week. Too late. And then I think we've got Paul Hanford contributed an example just for number 1 for kindergarten class. Why do birds sing? That's elegant, that's simple. But it's interesting in that sometimes we have to get into, I mean, it's one thing to come up with a catchy tagline, a catchy title, and then sort of being able to flesh it out and being able to come up with a summary, something that lasts long enough for a news clip. You know, if someone is advertising your event, being able to come up with a summary that's for that audience is sort of the next big trick.
Yeah, well, I think it's reasonable to recognize that we're limited in this particular venue right now to really flesh this out any more than just dealing with, say, headlines or at least a catchphrase. But clearly, the whole process of developing the entire talk would require thinking about everything you say on these various levels that I brought up. You know, specific to general, how to frame it, how to avoid the jargon, how to represent ideas or concepts in a way that will be easy for them to understand, and also to, you know, throw in as much as you can to engage and to activate the interest without overdoing it. And you know, that sounds like some kind of formula that you can follow, but clearly it's not as easy as that. It is something where you have to kind of get the right amount, not too much, not too little, and the only way we could do that is by thinking about it, discussing it, sharing with others, carefully planning one's talk, and also to practice as well.
So we've got a couple more contributions, but I think in the interest of time, we'll move forward. So thanks for those that contributed, and those that haven't contributed in the chat box. I'd encourage you to do this, you know, on your own, do this exercise, because even if you're not going to be speaking to an audience immediately, it can even really help you in clarifying the way you're thinking about your own work. So yeah, Adam, if you want, I'll take us to the next slide.
Okay, yeah, so this is basically just a concluding slide, and before handing off the webinar to Alana, I think it's just important to point out that for those of us that are willing to engage the general public, the scientific communication, that it's not necessarily going to be easy. That the skills are a part of it, but also there are other challenges out there. I think that the image clearly represents a type of challenge, that there's a lot of mistrust out there about science and its institutions, that there's obviously a lot of ignorance about what is science and its results. And so we have to recognize that it's important to communicate with non-scientists for the reasons that we'd already discussed earlier, but that it may not be easy, that we have to engage the disengaged and to try and bring some level of rationality to discussions that are often highly controversial or sensationalized when discussed. And also lastly, that the effective communication of science to the public is not necessarily about teaching everyone to be a scientist, but more so an endeavor that will hopefully reduce the amount of scientific ignorance that's out there, or resistance to science as a whole, so that the public who are not currently engaged or willing to be engaged can engage in discussions about science and hopefully use some of that information in their own personal lives as they relate to being in society with the rest of us. So on to you, Elena.
Thanks for that. That was really great, really simple crash course. And a quote that I quite like, that I think sort of sums up some of the moral impetus that you threw behind this, Adam, is that science cannot resolve moral conflicts, but it can help to more accurately frame the debates about those conflicts. So one of the things that that we as researchers, as academics, struggle with is this idea of we have this knowledge, we want to share this knowledge, doesn't necessarily mean we're telling people to do something or other. That's not really our job. Our job is to share the information and share it in a way that can be understood. So at this point, I'm going to get into the nuts and bolts of communication. So what are the tools? What's the press cycle? If you want to engage, how do you actually do it? So when should scientists communicate? In a cultural sense, in a national sense, now is the time. We've had a government change. The culture around science is changing. We're starting to see a little bit of loosening in communication. We don't have formal policies in place for federal scientists, and this is something that Evidence for Democracy is campaigning for, is to have guaranteed rights of last review and ability to communicate for federal scientists, which they couldn't under the Harper government, as was well documented. But there's more appetite from the public for science. Now is the time to capitalize on this moment, to be sharing our research, to be sharing the evidence with the public and with policymakers directly so that they have the tools they need to make the best decisions. We've got this culture of scientific openness. And another thing is we have new media. We have blogs. We've got Facebook, Twitter, Instagram, Snapchat, things that allow you to bypass the traditional gatekeepers, the journalists typically, and take your science directly to those who might want to consume it or to whom it might apply. So although we're not going to get into the nitty-gritty of new media, that's if you're a skilled communicator, if you're skilled at framing, and it takes practice for that, that's a great way to sort of bypass some of the blockades that come with working through journalism and go directly right out to your audience. So now is the time. Practically, though, when should you communicate about a particular issue? How, when you're using journalists, when you're using traditional media, how are they going to interpret your science, and how can you limit misinterpretation, and what are the tools to get there? So I'm just going to cover all those really briefly, just sort of a crash course in these practical aspects. Okay, so who engages with the press? If scientists don't engage with the press or with audiences directly, ultimately, we're just talking to each other. We're just in an echo chamber. So the first place, say you've published a study. It's a study on global migration patterns for a group of birds that are threatened by climate change. If the study is big enough, what will happen is your university is probably going to want to advertise it. They're going to say, oh, you were published in Nature. That's great. We're going to show that off. If you're not at a university, your department that you work for in your industry or government, you will have PR staff somewhere embedded who are going to want to share that, typically for posterity. Look at what great researchers we have. They get published in Nature. That's great. And those will share the contents, but they may not be aimed at an audience that's actually going to impact policy or that is going to get to the general public. So the next level is the scientific journal, the big journals, Nature, Science, some of the large medical journals. They'll have their own communications teams. They will pick a select few articles that they think they have the highest impact from each issue, and they will do communications on those articles that are a little bit more content-based. Often what happens from those is regular news media, news wires pick it up. They just snip out a sentence or two from there. Often they totally represent it in the process. And that's how, altered migration pattern from climate change may turn into all birds are dying because they're flying into the ocean. There's kind of this telephone effect that can happen from that process. But the thing that's different now with new media, but also with research that isn't going to get covered in those other ways, is you can engage with the press directly. You can make that happen. One caveat that I want to make here is that you got to make sure that you're ready for the ramifications of that. So when you start to get covered by the press, you're going to get comments on online articles, on Facebook, you might get phone calls, you might get emails. Some of them will be nice and some of them will not be nice. Harkening back to that image that Adam showed of scientist stereotype, you may have noticed that none of the pictures that came up were women. And I think it's particularly bad for women who are trying to communicate their science. They get their credibility undermined, they get threatened. So you have to be ready. If you're going to go to the press with something, especially something that has public impact or threatens people's ideas of the world, there's going to be pushback. So that's just something that you have to kind of steel yourself and be ready for. People always say, don't read the comments. And then we usually always do, but they say don't. I've been called a number of things in my time, commie leaf licker being one of my favorites, but I'm sure many of us have heard a few working, trying to disseminate our science. Okay, so you've got a study, perhaps it's published. You would like to share it with a wider audience. Are you ready? Not yet, not at the moment of publication. What you need to do first is you need to distill your message and make it press ready. So that means going through the process that Adam outlined, framing it, dropping the jargon, simplifying it, and choosing your audience. So using your audience to inform that. Choosing your audience in the specific case of communicating your work means picking what kind of media you're going to use. Are you going to call a CBC reporter? Are you going to post it on the Facebook page of your organization? Are you going to write an op-ed for a newspaper? And then you got to think about who's going to be watching that, or listening to it or seeing it, what's their level of scientific literacy? Going on a radio talk show versus going on Quirks and Quarks, local radio talk show versus Quirks and Quarks. You could get asked the same question. You have to be ready to give different answers based on who the audience might be. And then once you've got that ready, and I'd encourage practice, 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 tell your partner, your family, your colleagues, practice it with them, tell your dog, then you can utilize the press cycle. So that's when you're going to approach it, but how do you know if you have something worth going to the press over? Well, here's some do's and don'ts for going to the press. Go to the press yourself for big public events that you're expecting lots of people to come to, and big, I really mean over 30. Over 30 is probably fine, especially if you're in a small town. A rally, a panel that might attract a broad interest group of people. Research results or discoveries that are new, that are original. Don't do press for the study that you published in 2009. Particularly publications with public relevance. So environmental issues are often relevant. Medical issues are very apt. But there's a range of things from new technology all over the map. So consider, what is the public relevance? How is this going to impact somebody's daily life or make them pause in their day? So public relevance is important, but then there's also interest stories. Sometimes it's just very cool to learn about that new microorganism that happens to look like a box or whatever. We see those stories quite often. They're kind of feel-good science discovery stories. Those are also great for going to the press with. Another one is a new large partnership. So if you're starting a new multinational network, or you've got a big grant and you're going to start this new project, even if you haven't done any research yet, you can go to the press with this new large partnership and sort of talk about this thing that's coming into the world and all the research you plan to do and what the public policy implications of those findings might be. That's okay to go to the press at that point. And similar to the public relevance, research relating to an important contemporary issue. So, right now, self-driving cars. If you have any research on self-driving cars, no matter how small of a piece of the puzzle, I would guarantee you that the press would be interested in at least talking to you about it, because that's a topic that's starting to arise and growing on people's minds. Okay, so that's when you should do press. When shouldn't you do press? Don't do press if there's no public impact of your work or no easy to understand public impact. Don't do press for a scientific talk aimed at a scientific audience. I mean, you'll do advertising around it within departments, university, government, industry to get people to come, but you don't want to do public advertising. And don't do something that's ongoing or preliminary results. Nothing's worse than going out, sharing publicly what you expect to find, and then realizing you've got to put your foot in your mouth because you found the exact opposite and you had fanfare around the first thing. And not only does that hurt your reputation, but it also hurts all scientists in general when they're communicating with the press because it makes them seem less trustworthy and less certain. So those who, whether you have or haven't engaged with the press, I'd love to see some of your own ideas of do's and don'ts for when you should do press, things you should not do press for. Please share them in the chat. I see there's a question about how to determine which press. We will get into that. Okay, so once you've decided you have something, you think you want to go to the press with it, the next stage is using the press cycle. So the first thing that you do, and this applies across traditional media types. So I'm not talking about social media here. I'm talking about radio, TV, newspapers, magazines, news wires, etc. The first thing you start with is a media advisory that you send to reporters. So this means you have to identify your reporters or the group you want to talk to first before the event happens, the rally, the panel, or before the publication happens to notify them that this is coming out. That's the first step. The second step is a press release. And this you send to the same reporters that you contacted with the media advisory on the day of the event or the publication, right first thing that morning. And it includes all the background on the event. It includes what's happening or on the publication. And it's also, you want to include quotes. I won't get into the details because Carolyn Brown, no relation to Adam Brown, who I believe is on this call, is going to be giving our next webinar in early October that is a primer on press releases. So I'll tell you a bit about that before we close. Once the press release is out, you will be contacted for interviews. They may occur if it's an event. They may occur during the event. The press may come to your event. They may want to interview you, or they may want to interview someone else that's involved. So you got to sort of think about who is involved in this discovery or this research and make sure that everybody is prepped, not just you in case they want to talk to someone else. So that's the point at which interviews happen, which will support TV, radio, newspaper publications. Finally, there's also op-eds or editorials. So these are written by you, and Evidence for Democracy supports the network of experts in writing op-eds and editorials and getting them published in newspapers, magazines, or online news sources as well. So that's sort of after the event has happened, after your publication, after your event, you yourself can write a piece detailing why this has public policy impact or why this is a cool thing that everyone should know about and submit it for publication in a newspaper. And that's a really great tool that we are also going to look at in the future. As I mentioned, this is just traditional media, the newspapers, TV, radio, magazines, even sort of online news media like Huffington Post, etc., would more fall into this category. New media, Facebook, Twitter, blogging, that's a whole other beast, and it goes by different rules. So that's something that we're not going to focus on here, but there's lots online if you look for it. If actually Science Borealis has a number of really good blogs about how to use new media, but it is also something that we're hoping to cover in the future as well. Okay, so that's the basics of the press cycle, but it's not always quite so simple because of differences between the way scientists see things and present things and journalists interpret them. So I have a question for you, and if you want to share your story by audio, please raise your flag and we'll unmute you. So does anyone have an example of a time that they interacted with journalists and it went all wrong? or feel free to chat it.
Well, I could jump back in here. I've got a couple of anecdotes about things that I just found terribly embarrassing because I did something wrong. Well, the lesson I think to take out of both of these is that when you are on camera or in the studio talking to one person, journalist or somebody that is collecting your story for putting on air, always assume that everything you say is going to go on air. I have two instances where I felt terribly embarrassed because I didn't respect this rule, and something I didn't want to go on air did. One of them was before I was to give an interview with somebody for a local TV. I'd asked, is this going to be sort of run straight to tape and straight to air, or will you do editing? He said, we'll do editing. So halfway through the interview, I said, I didn't know how to answer something, so I said, okay, here, I'd like to go off record here and say I don't really know about this, that, or the other, or whatever. And we kind of agreed, all right, fine, and we went back into the interview. They didn't cut that out. They ran that on the show. It was so embarrassing that I almost died at having seen that. So there was that one thing. And the other thing is, if you're in the studio at a desk with others who are being interviewed for a topic, always assume that you are on the TV at all times. A lot of times the camera angle will change from one to the other, and you never really know which is the one filming at any given time. I remember during a talk show where I was on air, I picked food out of my teeth, and I was like full on the screen. I thought the camera was on somebody else who was speaking at the time, and there's a picture of me with my finger in my mouth trying to get food out of my teeth. It was so embarrassing. And these are just lessons that I learned by trial and error, not knowing that this is the case, but it's good to think when you're going into these things that you are on for the whole time that you're talking to this person. Don't step out of character ever.
Yeah, certainly there's that can happen. I've had a few of those instances myself. And you got to be ready. Practice, practice, practice. And like I said, we're just touching on the tips of it here. There's a lot more in depth that you can go in terms of really practicing to go on to be ready for interviews. So before you contact the press, even when you're just starting that media advisory press release phase, even before getting to interviews, you got to think about how they're going to interpret it, because that's going to color what they report, what clips they take out of what you say. Adam did a great job with that fantastic jargon table that I saw a bunch of people really liked that jargon table. We assume that everyone is using the same terminology. We assume that they are understanding it the way that we're putting it out. This is definitely not the case.
I just want to point out that that's not my table, that I did copy that from a manuscript on communicating science. So just to make it clear that I didn't come up with those recommendations.
Perhaps I'll have to get the link from you and send it in the package that we're going to send out to participants.
Yep, will do.
So when you're communicating with the media, you got to consider that there's this fact-value gap that I just touched on earlier. So scientists and researchers and academics, we tend to think about facts. Okay, this is empirical data about the world. You can test it, you can measure it. We think it's objective, or it's true, independent of who is doing the observing. That's how scientists think, or are trained to think. We should think in the practice of good science. But on the other hand, journalists are interested in values. They want things that create controversy. They want things that advance a discussion or create disagreement. So moral claims, rules, statements that contain ought or should or must, and things that are subjective or from a particular viewpoint. These things are like oil and water. They don't mix very well. And what you have to be really wary of, both in your own communication and the way that it's going to be interpreted, is that the media, to generate interest, to make it exciting, are going to try and take your facts and put them in values. And sometimes that's okay, but sometimes it can really spiral out of control in terms of, a statement about Migratory birds are changing their migration patterns, gets switched to sort of a disaster scenario of there's going to be no birds left in Atlantic Canada. You know, so they want to take that and translate it to something that's controversial, to something that's really values laden. Got to be ready for that. So in our own academic communication as scientists, we are rewarded professionally for reporting facts, laws, theories that are well-researched, that are documented, that are backed up. We get reprimanded for making value judgments. I wouldn't be surprised if many of you have early in your career been writing a discussion or a conclusion section and had your supervisor just scratch the whole thing out and say, nope, can't say that, that doesn't infer that, we didn't find that, that's taking it too far. It's a really common mistake that early career scientists make when they're learning the process. And so we try and keep that out of our academic communication. We report what we find, not so much what we think it kind of maybe might mean. On the other hand, journalists, they get rewarded for raising these controversies or issues, and they only get reprimanded if the facts are poorly researched or falsified or misrepresented. And often, even if that's the case, they don't get reprimanded at all, especially if they got a big story with a lot of hits. Just keep that in mind. Okay, so we are pretty much at our finishing time. I'd like to invite you to stay for a bit of Q&A after. But what's happening next? This was such a quick crash course. It's just the tip of the iceberg. We could spend an individual hour on, I think, each of the sections that Adam and I talked about. So this is the first in a webinar series for Evidence for Democracy's network of experts. For those of you that aren't already on the network of experts, I will send you an invitation to join. I will send you a follow-up package with a PDF of the slides from this talk, some supporting resources to take you a little deeper. And then the remainder of the webinar series is actually going to dig more deeply into how to frame your message using these tools and really getting yourself ready to bring your research to press. Our next webinar is Wednesday, October 5th with Carolyn Brown. Really excited about this one. This is media releases for scientists. So she has a ton of experience. She is a science writer and editor, has experience with so many media releases, successful ones, unsuccessful ones, her own, editing other people's, and is going to bring us lots of real world examples as to what you can do and what you shouldn't do. Okay, so now we'll enter the Q&A. If you want to ask a question by audio, you are welcome to, and you can do so by raising your flag and we'll unmute you. Or if you have questions that you want to enter into the chat box, please enter them. It would be great if you could address which one of the two of us you'd like to answer it, or we can both take a crack at it. We won't spend too long on the Q&A, and then I have a very, very quick wrap up after, so I hope you stay with us for that. There is a question here. Do you mind if we share the slides with colleagues who aren't able to attend? I will get back to you on that question as we're just kind of figuring out with this series. We do want it to be a network of experts initiative, a service that we offer our network of experts, which we also help our network of experts with communications. That's something I neglected to mention, that if you're on the NOE, you think you have something that you want to go to the media with, you want to craft an op-ed, you want some help, shoot me an email, give me a call, and we can talk about how you can make that happen. Any other questions? There was one that came up earlier that I'd like to throw to you, Adam, just as an example of framing. So Meg asked, what are some suggestions on how to describe endocrine disruption and risk versus hazard assessment of chemicals?
Oh, okay. Well, I'll address those two separately if I could. Endocrine disruption is, I think, just the term endocrine disruption is complex and probably too technical for most people. I think just referring to hormones is probably a better way to go, and say, I don't really know, I'm just kind of trying to riff with it here, but just try to point out that it causes problems in hormone systems or maybe even hormone related development. You could talk about how, hormones, I think most people conceptually get what hormones are, the molecules that run around and do stuff. So if you kind of just focus on hormones instead of the more technical system name of endocrine, and then the disruption aspect is really how it causes problems. The problems, my understanding, are largely developmentally. So you might want to talk about how, hormone imbalance, or even that word might be a little bit technical, lead to problems in development, particularly in animals. And you might also want to point out the role that hormones play in sexual development in animals, and that hormone problems related to hormones lead to problems in sexual development. I think that part of that concept, as I understand it, is that there's chemical mimicry involved, where certain chemicals act like hormones, and so you could, instead of saying chemical mimicry necessarily, say that there are chemicals out there that behave the same way as certain hormones do, particularly those related to the ones involved in sex development. And so really just kind of distilling it down to explaining what these are instead of relying on the terms would go a long way to allowing people to understand. I think most people would get that hormones play a role in animals growing and developing, and that if you have something in there that acts like a hormone when it shouldn't be there, that can lead to problems in this development, and particularly as it relates to the sexual development. You can, instead of talking about, demasculinization and feminization, you could say that, there are particular hormones that are more impacted upon by this mimicking or resemblance, and estrogen being one. This is a female hormone, and so if there are some chemicals out there that act like estrogen in males, that may prevent them from properly developing their sex organs or systems, and so on and so forth. So I'm really just trying to distill it down to what's happening, as opposed to relying on terms or concepts.
Yeah, that's a great explanation of taking something really, really technical and complicated and breaking it down to be a little more public friendly.
Robert, what was the other one?
I think we got a couple more questions.
Okay. All right.
I think that we'll move on to the next one. Robert asked, any points regarding engaging with a minister? Great question. We are going to address that in a future webinar. So the first part of the series is looking at communicating with the public, but we are also going to do at least one on communicating with policymakers and informing the policy process. So we are going to cover that in future. We won't cover it here today. Sorry that we couldn't fit that in, but it is upcoming, so keep an eye on your email for that. Another great question here from Fern is, and I think, Adam, you might be the one to field this one. If your results are misrepresented, how do you go about dealing with it? Can you try to clarify it, or is it something you just have to allow to be out there incorrectly?
Well, I guess that's a personal decision. My feeling would be not to allow it to fester. We've seen some of the effects of having misrepresented science linger too long. Just think of climate change denial, or GMO demonization, or anti-vaxxers, and all the damage they cause. So I think that if we were to talk more holistically as scientists, part of our obligation is to ensure that the science is accurately represented. It's a burden, but it is what it is. How you go about doing that? Well, you have to re-engage with the media or the public in some way. Social media can work. There are a number of sort of science communication dissemination vehicles out there. As Alana mentioned, there are ways to get in touch with the media so that they'll be interested in having you talk to them. So the question is, should we? I think yes, but it really is an individual choice. But I think most people that are here are on some level committed to that. So I would say yes, go for it.
And Carolyn also weighed in that on a basic level, if it's a factual error, you can ask for a correction to the story. Of course, you know, corrections come later, so usually the misinformation is already out there, which makes it a challenge. So I think it is sort of reiterates the need to really nail your framing and delivering and practice it in the first place to minimize the risk of being misinterpreted. I had to face that decision myself. Actually, the first op-ed I ever published, I was 18 years old. I'm not going to tell you what it's about because I don't want anyone to find it ever. I published it in a small university newspaper. It was picked up by 22 other outlets and republished. And I completely disagree with everything I said in that article. But for fear of public embarrassment, for fear of, you know, not being allowed to speak to the media again in that way, I just sort of let it slide and hope that with the passage of time, it got buried and, you know, it hasn't come back to haunt me yet, but you never know. So you have to realize that we're all fallible. We make mistakes. So you got to really be ready before you jump in. When I jumped in, I wasn't ready yet. And at some point, it's probably going to haunt me.
Yeah, and I think you make a good point as well that you pick your battles, right? Not every one of them is worth fighting for. Misrepresented science can have dramatically different consequences depending on what is misrepresented and how. If it's really something that's just personal embarrassment as opposed to causing dramatic problems in society, we probably can just let it slide.
Right. Well, I think that'll conclude. Thank you all so much for coming. We had a lot of folks on the call, actually, you know, more than we expected might be interested in something like this, a real range of backgrounds and experience. And I hope that this was useful for you, that there's some pieces of this that you can take forward. And I hope that you join us for the next one where Carolyn gets into some of the nitty gritty of press releases. Press releases are so key to getting picked up by traditional media. I am going to email all of you a short questionnaire for your feedback to help us improve future webinars. That will come to you either later this week or early next week. And also, as I mentioned, E4D is here to support the network of experts in communication. You can contact me anytime. My email address is here. If you've received an email from me, you have my phone number, and we can talk about some of the specific questions for your research. Who would be the audience? Who would be a good choice to go to the media with? And I can, you know, give you a hand in developing some of that framing. So thank you so much. Any final words from you, Adam?
Nope. Just thanks for inviting me, and thanks everybody for coming along.
And a huge thank you to Adam, who volunteered his time to develop and deliver this. And it's been a long process, but I think we came with a great result. And also thanks to Kathleen for moderating and helping work out our technology issues. So if you want to stick around in the chat and bounce some ideas around, feel free, or else we'll see you next time.